Diffusion can be described as molecules flowing from high concentration to a low concentration, and usually from one central point. And how I'm going to show this is through heat. So I have an infrared thermometer, and as you can see, this filing cabinet is around 74, 73 degrees Fahrenheit. Around my hand is around 82. So if I place it on this, I should see places around the cabinet that are higher than 74 degrees. So you can see it's around 73 over here, but as I start to get closer, it's going in the high 74s, and if I get in between my index finger and my thumb, right here, it's 75. So this shows that heat is transferred from my hand into the cabinet, and it is diffused throughout different parts, because there is more heat in this central point than there is here, so it's going to start going outwards. Here I am modeling the fluid mosaic model and the semi-permeable membrane, or the cell membrane. So this quilt represents the cell membrane. As you can see, the smaller molecules can pretty easily just fit through the cellular membrane, but if you take the bigger ones, they just don't fit through. So what do you need? You need a protein channel, or a gated channel, that's a little bit bigger, and they can fit these bigger molecules through by having an opening, and you can just let them in with a concentration gradient. Concentration gradient can be showed with gravity and marbles, or at least in this model it can. So, concentration gradient. There are a lot of marbles up here, but not a lot down here. So it is going to diffuse and go into the cell, or just into a place of low concentration. But active transport, it needs to be actively lifted, or it needs like outside power to go up, because it's never, marbles are never going to go up. It's not gonna work. You need to have some outside force to pull marbles up. So that's what active transport is. It's the cell using its proton pumps, and it's squeezing those, or pushing those molecules up and into the cell. To show active and passive transport, I'm going to be using gravity once again. So there's a high concentration of marbles up here, but there's a low concentration down here, let's say. So if you have it, if the marbles can pass through, they will diffuse and go towards the low concentration until they're equal, or until they're at the same level. And active transport is where you have a proton pump, and then if you put a molecule in there, the cell has to actively use power and push the molecule through into the cell, or out of the cell, depending on the concentration gradient. And if it was pushing it out of the cell and the concentration gradient was already doing it, then it wouldn't need to do that, and it would just do facilitate diffusion. Exo and endocytosis. So, how Endocytosis is where cells are attached to some proteins that attract it, and when they have enough, it creates a little divot, and when it goes around, it attaches, and then the cell membrane just attaches to itself and then goes in, and then these molecules are stored in a little vesicle, and whenever it's used, and then we have new waste cells that need to be out of the cell, or something that needs to be used elsewhere, it will float across the membrane, attach, and then just, well, detach and go out. And the cell membrane still stays intact all the time because they, as you have seen with these magnets, they can easily just be rearranged and have like a vesicle. Attach and then be reintegrated into the membrane. Facilitated diffusion. Here is our cell membrane, and here are some molecules. So the concentration gradient is down, we could say, because of gravity and how things fall down. So if I place this here, it will go into the protein channel because concentration gradient allows it to, and there's a big enough hole. It can't fit through this piece of paper, but if there's a channel or something it can go into, it will. So it's diffusion in the way it's going into the cell without any active power, but it's facilitated because it's kind of helped, but it's not a lot of power, or it's not power taken from the cell. Here I am modeling osmosis because the water level is the same in both the cell and outside of the cell. And if you put more water, or if there's more of something outside of the cell, the concentration gradient will bring it up in the cell as well. And to model a proton pump, I have this little air vacuum, and it is actively transporting things into the cell. You can't really see it because it's behind the label, but you can see it. It's actively taking things into the cell. So proton pumps can actively bring things out of the cell. So you can see here, it is pushing it out of the cell, going against the concentration gradient. In this model, the water bottle is the cell, and the solution is isotonic to the cell. Now if I pump some of it out, the solution outside of the cell is hypertonic to the inside. And if I do the opposite, then the solution is hypotonic from the cell.